Okay, let's just jump right in with this. This celestial riddle. It sounds like a flat-out impossibility. Could you actually have a planet where a single day, the time it takes to spin just once, is longer than its entire year?
It seems like it should break some kind of law of physics, right?
It really does.
Everything we experience, our whole definition of a calendar, is based on lots of quick days inside one long year. But the answer is a definitive yes. This temporal paradox is very real.
And the planet in question is our neighbor, Venus, or Alzura, as some of our materials call it.
Exactly. And I think that one fact that its day is longer than its year is probably the single most shocking piece of information in this whole deep dive.
I agree. It's just mind-bending.
So our mission for you today is to really extract the science behind that. We're not just going to state the fact, but dig into the mechanics that make it possible.
Right, we need to understand why. Why does Venus seem to run its cosmic clock completely backward?
And what are the strange kind of inverted consequences for anyone or anything that would be there?
The contrast is just.
Yeah.
It's so dramatic when you look at the numbers. Venus takes about 225 Earth days to go around the sun. That's its year. Pretty cool.
Yeah, shorter than ours.
But to complete one single rotation on its own axis, just one day, it takes 243 Earth days.
It's incredible. It actually finishes its orbit its entire year before it is finished spinning once.
That ratio just forces us to throw out every single assumption we have about how time on a planet is supposed to work.
It's a total recalibration. I mean, on any other planet, orbit and spin, they sort of align intuitively.
Sure.
But on Venus, the orbit is it's a relatively quick dash, while the spin is this agonizingly slow crawl.
So let's drill down into that. We've established the rotational period is longer than the orbital period, but the why is the interesting part. Is it just about being slow?
That's the perfect question, because slowness is part of it, a huge part, but it's not the whole story. And this forces us to bring in a really critical concept, which is the difference between a sidereal day and a solar day.
Okay, yeah, let's clarify that for everyone listening. What are those two, and why do they matter here?
So a sidereal day is let's call it the technical precise measurement. It's the time it takes the planet to spin exactly 360 degrees on its axis.
Relative to the distant stars, right? The fixed background.
Precisely. For Venus, that's the big number we just mentioned, the 243 Earth days.
And a solar day is what you'd actually experience.
That's it. It's what you would see if you were standing on the surface. The time it takes for the sun to get back to the exact same point in the sky.
So sunrise to sunrise.
Yep. It's the measure that actually determines your cycle of light and dark.
Okay, and on a planet like Earth, our solar day is, what, about 4 minutes longer than our sidereal day?
Close. It's the other way around. The sidereal day is slightly shorter. It's 23 hours and 56 minutes.
Oh, right. Because as we're spinning, we're also moving forward in our orbit.
Exactly. That little bit of orbital movement means we don't have to spin a full 360 degrees to bring the sun back overhead. The orbit gives us a little boost.
So our fast rotation and our orbit work together in a sense.
They do. Now, if Venus were just spinning slowly but in the same direction as us, what we call prograde, that same thing would happen.
Its orbital movement would still help shorten the solar day?
It would. Even with that incredibly slow 243-day rotation, the orbit would chip away at it. The solar day would definitely be shorter than 243 days, and therefore shorter than the year. The paradox wouldn't exist.
Okay, so this is where it gets really interesting. Since the day is longer than the year, something else must be going on. The orbital movement must not be subtracting from the spin time. It must be adding to it.
You've got it. That is the crucial connection our sources make. The paradox exists not just because of the slowness, but because of the specific, very unusual direction of the spin. And that brings us to the second core mechanism, retrograde rotation.
Retrograde. That word does a lot of work here.
Yeah.
It basically just means it's spinning backward.
It is spinning backward. While Earth and, well, most other planets spin counterclockwise, Venus spins clockwise. It's going against the grain.
Can you give us an analogy for that?
Sure. Think of it like walking on a moving walkway at the airport. Earth is walking forward on a walkway that's also moving forward. You get to the end faster.
Makes sense.
Venus is walking very slowly on a walkway that is moving backward.
Ah, so that backward motion of the walkway, the orbit is working against you, making your journey take longer.
It dramatically alters the calculation. The planet is rotating backward, but its orbit is still going forward. So to get the sun back to the same spot, it has to rotate more than 360 degrees, not less.
The orbit is making the sun take longer to return.
That's the mechanical insight we needed. The orbital motion, instead of helping, forces Venus to spin even further to catch up with the sun's position. And this results in a solar day, the sunrise to sunrise time of about 117 Earth days.
Wait, 117 days?
Yep,
But that's shorter than the year, which is
Yeah.
225 days.
it is.
So this is another layer to the confusion.
It is, and this is a perfect example of why a deep dive like this is so important. You have to distinguish between the different kinds of day.
Okay, so let's get this straight. The sidereal day, the true 360-degree spin, is 243 Earth days. That's longer than the year.
Correct.
But the solar day, the cycle of light and dark you'd actually see, is 117 Earth days.
Also correct.
So when we say the day is longer than the year, we are specifically talking about the sidereal day.
That's the one. But the ultimate cause for this entire unique temporal system is what our sources call Doron Aksiwabati Jidan,
Which translates to,
a very slow and reverse rotation.
yeah.
That is the fundamental physical state of Venus. The combination of that extreme slowness and the backward motion generates all these weird numbers that seem so paradoxical to us.
And it's not just slow. I mean, it's glacially slow.
Oh, it's almost stationary.
On Earth, if you're standing at the equator, you're moving at over 1,000 miles an hour.
Right.
On Venus,
Yeah.
what is it, like 4 miles an hour?
Yeah.
You could literally outwalk the planet's rotation.
You could jog faster than the planet is spinning. That extreme slowness is why the planet's orbit and its thick atmosphere just completely dominate everything. The planet is almost, locked in time.
So we have this trifecta, a very slow spin, a backward spin, and a solar day that lasts for months on end. If you were standing on Venus, and let's just pretend you could survive the crushing heat and pressure,
A big assumption, yes.
how would this retrograde movement actually look? What would you see?
Well, it would fundamentally flip your entire observable universe. Everything we use for orientation would be reversed.
Okay, so for us on Earth, the most basic fact of life is the sun rises in the east and sets in the west.
It's the foundation of navigation, of timekeeping, of everything.
But on Venus,
Because of that retrograde, that backward spin, the sun's apparent path is inverted. You would see the sun rise from the west and set in the east.
wow, an entirely inverted reality.
And because that solar day is 117 Earth days long, that journey across the sky wouldn't take hours. The transition from sunrise to sunset would take weeks, almost 2 full months of daylight.
Imagine that. You watch the sun peak over the horizon in the west, and you know you have about 2 months of daylight ahead of you, then 2 months of night. Our whole concept of a 24-hour cycle is just meaningless there.
It really makes you question what a cardinal direction even is. Our east and west are just, functions of our planet's rotation. Flip the rotation, you flip the map.
Which brings us to the theme that one of our sources uses to tie it all together, that everything on Venus is Mike Loop, inverted.
It's the perfect summary because it connects all these different strange facts into one coherent idea.
So let's list them out, the 3 specific things that are inverted on Venus.
Oh, okay, so the first, and the one we started with, is the relationship between the day and the year. The sidereal day is longer than the year. That's inversion number 1.
Right. Number 2 would be the planet's own movement. Its rotation is flicked, it's spinning retrograde against the flow of almost every other planet.
And third, the direct observable consequence of that. The direction of the day is inverted. The sun rises in the west and sets in the east.
It's a powerful demonstration, really, that our most deeply ingrained assumptions that a year has hundreds of days, that the sun rises in the east, they aren't universal laws.
Not at all. They're just common patterns that we happen to see in our little corner of the cosmos.
When you look at Venus, you realize that our ideas of time and direction are just local custom.
Exactly. It's so central to thinking like an astronomer. You can't just project Earth's standards onto every other world. You have to analyze the specific and sometimes truly bizarre physics of each place.
So to recap the key nuggets of knowledge we've extracted for you, Venus is a planet of extremes. Its incredibly slow backward spin creates 2 huge time distortions. First, its true rotation period, the sidereal day, is longer than its orbital period, the year.
And second, that retrograde motion flips the sky, making the sun rise in the west and set in the east. It is, without a doubt, the solar system's inverted planet.
A truly mind-bending place, and it's right next door.
It really confirms just how much diversity and complexity there is, even in our own solar system.
Absolutely. Which I think raises a powerful final thought for you to consider. If fundamental concepts, like the definition of a day or even the direction of the sunrise, can be completely reversed just one planet over from us, What does that imply for everything else we assume is normal across the billions of other solar systems out there?
That's a great question.
We might be the unusual ones. The cosmos certainly doesn't know our definition of east or west, and definitely doesn't care about our concept of